Hi guys, Norm with you again, and this is just a little test video really. I'm recording this on the Doogee V40 phone using the Open Camera app and the Plantronics Bluetooth headset. Hopefully it is recording from the Bluetooth mic and hopefully the levels are okay. So this is what this video is all about, just testing to see what's going on with it. So what I'm going to do today is I'm just going to have a look at this Kenwood battery pack. This is from a VHF handset that I've got, and I've opened this before and I've pre-opened it now because I had to replace the thermal fuse. The battery was totally dead. It wouldn't take a charge, it wouldn't do anything, and so I opened it up and I checked, and that thermal fuse was blown. And now I've repaired that, and it operated on the radio for a bit, but this will not charge. So I've got to work out whether the cells are bad or whether it's something else on the circuit board that's bad. So let's see what we're on. Loop 3, stop at 2.7 and go. Yeah, go. Right, so what this will do, this will discharge it and then charge it up 3 times. Now that went into discharge very quickly. It shouldn't have gone into discharge until it got to like 4.2 volts. I don't think it did that. So it's probably safe to say that this cell is bad. Let's just whiz out a little bit. So far, this camera and this phone, this is the Open Camera app. Because the built-in camera doesn't allow the Bluetooth mic to work. But yeah, so it does look like this cell is probably bad. So here we are with the second part of this video. I did film the first part several weeks ago while I was waiting for the new cells to be delivered. Initially I thought these were 1000 milliamp hour cells, so the ones I bought were 1000 milliamp hours. But upon looking at this again, yeah, focus please. Oh, not liking it, is it? Is that 1950? I believe that says. Yeah, 1950. So these cells are probably a little less than what they should be. Refocus please. Yeah, so these cells are a little bit less than what they should be, but I reckon 1000 milliamp hours will be enough for that handset. So these are the cells I bought, obviously, and they are a lot smaller. I mean, we could probably get away with squeezing 4 of these in there, and that would give us like the 1900 milliamp hours, but we're not going to do that. I'm just going to stick to 2 of them, and that's going to do it. And you can see I've got numbers written on these. That's 935, and this one's 935 as well. And I did test all of these. This one comes up as 894 milliamp hours, and the next one was 904, 930, and where are we? This one originally tested as bad, but then I realized the problem with my tester. When the tester is running off battery, it registers the cell as bad. But then I retested this one when I tested all the others. I retested this one when the tester was plugged in, and it came up with 972. So that was the highest one. We've got some here. This one is 950. Yep, 950. I've got 955. What is there? 958 and 960. And so I wanted to choose the two that were the best matched, and these both read 935, so they will be the ones to fit in. Alrighty then, so now I've got to try and separate these cells from, there is a ribbon cable underneath there, which is not really very nice. I don't really like that. And so I'm going to try and get these old cells out without damaging the ribbon cable if I can. I mean, it might be hard and we might have to destroy the ribbon cable after all, but if we can get these out without destroying that ribbon cable, it will be nicer and easier to fit the new cells. Yep, that's one end of that cell disconnected. Okay, so let me just do that. Let me just make a mark on here so we know that is negative. On this side, that was negative, and all is good. Alright, so let's get this last one out somehow. Come on. Oh yes. Perfect. That come out without too much force. Alrighty then. So that's the empty shell case now. Empty battery case, I mean. And yeah, oh, that's weird. We've got a bit of wire going across there. Obviously where they've put a separator in the middle. Here you can see they've had to bridge that with a bit of wire, which is interesting. Okay, so that all looks okay, and these two will obviously fit in there and in there. Yeah, so let me turn the soldering iron on, which I should have done beforehand to get it warmed up, and we'll get these soldered in, and hopefully the editing, I can edit out a load of this crap. Okay, so there is the cells basically soldered into place, or soldered in. So pluses here and minuses there. 7.9. Why didn't they get that before? They were 8.16. So how was I reading it? Okay, so it's definitely on these two outer ones, or the middle and the outer, 8.16. That's perfect. Okay, so here is the charger. It is a genuine Kenwood charger with this very cute little switch mode power adapter. You see that? Yep, nice cute tiny little thing. I mean, it's in some ways better to have a plug-in wall wart rather than this thing, because it's got quite a long lead and it does get tangled up quite regularly. But anyway, so when we put this in there, it should go red, and that indicates it's charging. and indeed, if it keeps flashing means it's not working. Okay, so I basically sorted this out now, but a lot of the footage of that has been lost and is not available. But basically, I couldn't get the original charger to work with the circuit board in the battery, and so what I've done now, as you can see there, if it will focus, I've got a USB-C port in the battery, and then when we plug in the USB-C, we have the red light, and the blue light there is lit up as well because the battery is pretty much fully charged. And so when the battery is fully charged, the red light will go out, but when it's kind of like nearly fully charged, you get the both red and the blue. When the battery is empty, of course, you just get the red light coming on. And that now is the charger for the handset, and that works really as good as anything. And so yeah, because I didn't want to risk buying another Kenwood charger only to find out that it was a problem with the battery circuit. And indeed there was a problem with the battery circuit, because when I first wired up this USB-C little charge board, it's very similar to like the TP4056 charge boards for the single batteries, single cells, but this one is 7.2, so it does the both. And yeah, I mean it works well. I mean, obviously the hole here isn't great, it's not really the best of holes, but I mean it does the job for now. I mean, we could tidy that up a bit perhaps, but as I say, really the cosmetic side of things, as we've seen probably with the Audio Line 340 and what have you, the cosmetic side of things is not really my strong point. But the main thing is now this radio is fully working, it's been resold, and it's got a USB-C charger, which is great, because I did think about putting the charge board into this, taking this circuit board out, putting the USB-C charger in that, and you can stand the radio in the dock to charge it. But I thought, no, it's just better, you can just plug the radio into USB-C and kaboom, superb. So that's it. Sadly, a lot of the interesting stuff of me checking out that charger and the charge board and the battery, sadly a lot of that footage has disappeared. But yeah, I did use the big dummy load there, and yeah, things. But anyway, that's enough yabbering from me. So this is the Kenwood 2160, is it? I think 20. Oops, my USB-C adapter came off then. Okay, so this is I believe it's a 2160, and of course starting with a 2 means it is VHF. Yes, 2160. It's not going to focus on that, obviously. There we are, TK2160. And as I say, with the Kenwoods, if it starts with a 3, it's UHF. Starts with a 2, it's VHF. So all I've got to do now, obviously, is give this a bit of a clean. Ye gods, that does look a bit scrappy, but I won't do that on video. Just give this a bit of a clean, and then it's all done. So there you are, guys. Thanks for watching. Cheers for now.